Hey, it's Bree from Scholastifair. Please like, share, comment, and subscribe to the channel. In this lesson, we will discuss how to name alkanes using IUPAC. Alkanes are organic compounds that consist of single bonded carbons. Alkanes are the simplest hydrocarbons and are the least reactive. This video will feature multiple examples with detailed explanations. In this lesson, we will be naming alkanes using the IUPAC naming system. Step 1 is to identify the parent chain, which is the longest continuous carbon chain. It's also referred to as the parent backbone. And since we're dealing with alkanes, the parent chain should consist of all single bonds between each carbon. Step 2, identify the substituent groups and include the locant. So substituent groups are groups of the molecule that are not included in the parent chain. And we have to name them and also ID them or attach a locant or a number so that we know where on the parent chain they lie. Step 3, complete the name, which is just to alphabetize the substituent groups, include the locant, and place the parent chain or suffix at the end of the name. And the IUPAC, which stands for Internal Union of Pure and Applied Chemistry, is an internal naming system for compounds. The purpose is to give each structure an unique name, which ultimately correlates to its unambiguous structure. So alkanes end in the suffix -ane. Dashes always go between numbers and letters. So for example, if we have 2-methyl-octane, the 2 is the locant and it represents where the methyl group is on the parent chain, which in this case will be octane. If you have multiple substituent groups that are the same on the parent chain, for example, multiple methyl groups, a prefix is needed. Substituent groups are arranged in alphabetical order and the parent chain is placed last. So, for example, a molecule that has multiple substituent groups, you have to alphabetize them. However, in some cases where there's just one substituent group, alphabetizing is not needed. The substituent group would just be placed in front of the parent chain. And hyphenated prefixes such as di, tri, tetra, n, and t are ignored when alphabetizing, but other modifiers such as iso, neo, and cyclo are not. And below is a table of the number of substituents and the prefix that goes with it. So if you have 2 methyl groups, then you would use di. If you have 3 methyl groups, you would use tri. And if you have 4 methyl groups, you will have tetra. Now, if you have, for example, a methyl group and an ethyl group, well, then a prefix is not needed because there are 2 different substituent groups. So when you have multiple of the same substituent group, a prefix is needed. Before we start actually naming alkanes, let's first discuss some common substituent groups that you may see attached to these molecules. So a substituent group is a side chain group that branches off of the parent chain. So when we are naming a molecule, first we want to identify the parent chain and the substituent group, as the definition states, is branching off or away from that parent chain. So the common groups that we have here is methyl that has 1 carbon, ethyl has 2 carbons, propyl has 3 carbons, and so forth. I would encourage that you commit these to memory as when you're doing the problems, you want to be able to get through them quickly. And the only way to do that is to start to commit some of these structures to memory. Now, there will be some cases where there are going to be other substituent groups outside of the ones listed here that you'll need to take into consideration. So, for example, let's say you have a molecule that has an alcohol and an aldehyde. Well, you're going to have to figure out, based on the priority list, which one is going to be a part of the parent chain and which one is going to be a substituent group. But in a later video, we will discuss how to name molecules that have more than one actual functional group attached to it. Remember, when trying to locate the longest carbon chain in alkanes, it is a continuous chain of single bonded carbon atoms. So in this part of the video, we're going to discuss how to correctly do the first step of naming molecules using IUPAC, which is to find the longest carbon chain. In this part of the video, we have two images of the same molecule, but I'm going to show you different ways to number the parent chain. So let's take the image on the left side of the screen and let's go ahead and number it. So in this case, I numbered first using red ink from left to right, starting from 1, going all the way up to 9. And then in the reverse, I numbered starting at the right, going from 1 to 9. So the purpose of numbering in this sequence or different order is because when you do this, you're going to see that the substituent group that is attached to the longest carbon chain, in this case, the longest carbon chain consists of 9 carbons. So it will be nonane with the suffix of ane at the end. So you'll see on the screen that you have a propyl group with the locant of 4 going from right to left, and then the locant of 6 going from left to right. So remember, we always want to choose the substituent group that has the lowest number. So in this case, the correct ordering of the parent chain is going to be in blue ink going from right to left. So we're going to take the image on the right hand side of the screen. I'm going to take my red ink. I'm going to start at carbon 1 going from left to right. So start horizontal, and then I'm going to make my way up vertically on the molecule. And then I'm going to take my blue ink and I'm going to start vertically and make my way down and then back to the left hand side of the molecule. So as you'll see, once we finish numbering the longest carbon chain, it still has 9 carbons. But it is numbered differently in comparison to the other version of this molecule, which is okay. And in some cases, you may not be able to number a molecule straight across horizontally or straight up and down vertically. You may have to do some twists and turns or start horizontal and end vertically and vice versa. The point is that you want to find the longest continuous carbon chain, and you want to have the correct numbering that the substituent group, if you have any, have the lowest locant. So now that we've identified the longest carbon chain, let's go ahead and identify the substituent groups of each molecule. So I'm going to use my green pen, and each corner of the substituent group represents a carbon. So I have 3 dots that I've placed on each corner, which represents a carbon, and we have 3 of them, so that is a propyl group. Now the image on the right hand side of the screen, we have the substituent group going horizontal this time, and I've used my green pen again. We have 3 dots, so that means it's 3 carbons, and that is also a propyl group. So now we can do the last step of the process, which is to complete the name. We have identified the parent chain. We've also identified the substituent group. So let's take the image on the left side of the screen. Remember, we first numbered the molecule or the parent chain from left to right in red ink and from right to left in blue ink. So when we number from left to right in red ink, the propyl group or the substituent group falls on the number 6. However, when we number in the reverse, from right to left in the blue ink, the substituent group falls on the number 4. So remember, the substituent group always needs the lowest locant number to be correct. So in this case, since 4 is lower than 6, the numbering from right to left in blue ink is the correct numbering. So the final name should state 4 hyphen propylnonane. So we place the number 4, the locant. It always has to be in front of the substituent group that it corresponds to, and it always needs to be a dash. Second goes the name of the substituent group, and then lastly is the actual parent chain name with the correct suffix. So since we're naming alkanes, the suffix ane goes at the end. So now let's look at the image on the right hand side. So again, we've figured out the parent chain, we figured out the substituent group, which is propyl again in this case. So we numbered in red from left to right, and the substituent group falls on the number 6. However, when you number starting from the top or vertical in blue, going all the way down and back left, the substituent group falls on the number 4. So again, 4 is lower than 6. So the final answer for this image on the right side of the screen is going to be 4-propylnonane. So as you can see, both images we numbered in a different way. However, both give the same final answer. So if done correctly, you should get the same answer. And the goal is to find the longest continuous carbon chain, number it correctly so that the substituent group has the lowest locant possible. Okay, so next example, let's go ahead and identify and number the longest carbon chain. So let's start from right to left, starting at carbon 1. And as we count, you'll go all the way up to carbon 5. So you may ask, why didn't I start from left to right? And the reason I didn't is because I'm keeping in mind the substituent group in this case, which is a methyl group, has to have the lowest locant possible. So if I was to number from left to right, that numbering would not give us the lowest locant. However, from right to left does. So the substituent group plus locant in this case would be 2-methyl. So now the third step, which would be to complete the name. So the final name is 2-methylpentane. So remember, the locant number goes in front of the substituent group with a dash. The substituent group goes in front of the parent chain. And since we are naming alkanes, remember that the parent chain, which is pentane in this case, has to have the ending of ane. Okay, so let's attack this problem. Let's first find the longest carbon chain. So if I start from the left side and go horizontally straight across, I'll start at 1 and I'll end up at 6, but I do believe that this molecule has a longer carbon chain than 6. So I'm going to start at the very top. I'm going to use blue ink and I'm going to follow the natural direction of this pathway. And once I do that, I end up at carbon 7. So it seems to me that the longest continuous chain for this molecule is heptane. So once I've done that, now I need to identify the substituent groups. So in this case, there are 2 substituent groups. You have 2 methyl groups. But also I need to add the reverse direction of this pathway. So I'm going to use red ink and I'm going to go starting at the bottom and then work my way up, follow the natural direction. I should go all the way up to the top. So once I've done that, I have the 2 pathways. I have the 2 pathways color coded in different colors. So I need to find the substituent groups and the locants. And the purpose of numbering in 2 different colors is that I want to find which pathway or which direction has the lowest substituent groups. Okay, So looking at the blue direction, or the numbers in blue, we have a substituent group methyl at number 3, and then we have another methyl at number 6. So I'm going to go ahead and write that down. And we also have, if we look at the reverse direction in the red, we have a methyl group at 2, and we have a methyl group at 5. So a trick that I like to do when I have multiple substituent groups and I have to consider multiple locations, for each pathway you're going to add the location numbers together. So for example, if we take the red pathway, where we have a methyl group at 2 and 5, well, 2 plus 5 is going to give me 7. Now, if we take the other pathway in blue, we have a methyl group at 3 and 6. So 3 plus 6 gives me 9. So when you add those two together, whichever pathway gives you the lowest number, that is the correct numbering for the parent chain. So in this case, the red pathway, or the substituent groups located at 2 and 5, give us a lowest combination. So that is the correct pathway for this problem. So the final answer is 2,5-dimethylheptane. So we have to include the two locations where the methyl groups are located. We also have to include the di, which is a prefix that goes in front of the substituent group name. Lastly, we have the carbon parent chain name, which in this case is heptane, and the suffix ane because we are naming an alkane compound. This concludes today's lesson on naming alkanes. Don't forget to like, share, and feel free to comment. Here at Scholastifair, we offer one-on-one tutoring and other resources for students. Feel free to check out our blog for more practice on the topic of this video. Till next time, bye for now.